Hey, good morning, guys. The board is functioning. Well, the beginning of it is, anyway. Let me fire it up here. And got 3 power supplies are working down here. The microprocessor's working, and it's running at about 0.8 amps at about 250 or 60 RPMs, and I've got a lot of adjustments on any 5.5 timers here. This is where the Hall effect sensors come in. They're all working good, and the 3 phases goes out to the motor here. I've got 120 from the variac coming in here. This connector here will be from the inverter, and this 120 comes in here to run this power supply, give me the 15, the 12, and the 5 volts. And eventually this circuit here is used to convert DC voltage to another DC voltage, so I can adjust it for 12.85, 13, whatever, to recharge the batteries or the capacitor bank. This circuitry in here is used to control the primary ground, 2 ends of the primaries on a transformer with the center tap has a positive DC going to it that provides a ground path for that, and that's isolated. This whole area here is for the high voltage power supply. That's putting out now about I think about 60 volts. The variac's sending out 50 volts into this sine wave, and then each one of this one here, this one, and this one, those 4 things are for the 4 ECM generators. There's I think I have some, since I haven't adjusted the timers on the pulses that do the loading and dumping of these caps out these connectors. There's nothing connected to the output, but there's definitely some loading going on with the motor. That's why it's at 0.8 instead of like 0.5 or something. So anyway, it's very quiet. It runs smooth. I don't have the counterweight on it, but all the ECMs are turning, and everything looks good there. The problems I had was the switch in here was bad, so I simply glued another one to the outside because it has 6 pins instead of 3, so I can't stick it in there. The other problem was the initial finding where the ground plane was all screwed up. You can't, with PCB WEB software, you can't have 2 ground planes with the same name. If you do, one of them never gets poured right. It just pours copper. It doesn't care about traces or anything. It just pours solid copper. So I had to grind out with a Dremel tool all these caps, the bridge, and some circuitry around the I-ramps for the high voltage supply. The fan goes here. This is a little DC 12 volts with some filtering for the fan, and I haven't used it yet. I've been wanting to monitor the temperature of this to see if I don't even really need the fan at this point, and because the heat sink is very, very cool. Actually, a tiny bit warm. But anyway, this is for remote high voltage, this connector. And this circuitry here uses a triac to manipulate and control AC. And that's another way of doing a variac if I wanted to. So I've bypassed that whole circuit for now to run the board. So next step, take measurements, do the adjustments, and we're off and running. So far, looks good. I just got to fix some of the wires, are kind of messy, and I'll clean that up. And the goal is to run this with a battery inverter. Energy comes back from the ECMs to recharge the battery. Now, I want to replace the battery with the 500 farad capacitor bank. And once that's done and it's running and self-running, this whole project is completed as far as I'm concerned. And we'll see where they want to take it. Anyway, have a great day.